Setting up a new project in Proteus is made easy using the step-by-step New Project wizard. The first dialog lets you name the project, pick a safe location for it, and define what sort of project you are creating. The next screen allows you to pick a template for your schematic design if desired. More details regarding creating your own template can be found in the documentation. Repeat the process for your PCB layout if required. Several standard board templates are provided with Proteus, and like the schematic, you can create your own. For the purposes of this design, the default style will be used, allowing for user definition of the board in Aries. You are now presented with the option to define your stack-up and drill spans. These settings are used for via ranges during routing. Since our PCB will be a simple 2-layer board, no additional configuration is required. The firmware can be left as no project if you're not using Proteus VSM for your design. The final configuration step is to review your chosen settings and continue if you are happy. If you're not, you can go back at any point and change the settings selected. The first thing to do in the schematic is pick the parts we'll need from the library. The library picker matches the selection as we type, making it easy to find the parts we want. Double-clicking the mouse on the LM358 will then bring it into the parts bin ready for placement. We'll do the same thing with our connector and then pick some passives for the design. The keyword entry is very useful here as we can describe what we're looking for. Typically, using capacitance or resistance values along with packaging narrows down the results list significantly to pick the device you want. We'll start the design by placing the LM358 dual op-amp. Simply select the part from the parts bin and left-click to start placement. The plus and minus keys on the keyboard allow you to rotate the part as you are placing it. A second left-click will complete placement. Place the connector in exactly the same way. Like most CAD packages, Proteus uses ground and power terminals to denote power nets, so we select terminal mode, then place a ground terminal alongside the connector. Wires can be placed at any time in any mode, so we simply click on the connector pin and then on the terminal pin to complete the connection. We then switch to power terminal type and repeat the process with connector pin 1. For clarity, we've then edited the terminals and named them VCC and GND respectively. Powering the op-amp is done in exactly the same way. When we need to insert a passive, we simply select it from the parts bin and drop it over the wire at the point we want to place it. Next, we wire the connector input to the inverting input of the op-amp. Note that when placing a wire, we can left-click to anchor a wire and change direction. The non-inverting input can be connected up next with a potential divider to provide the bias for the op-amp. After wiring the feedback loop, we complete this section of circuitry by adding a coupling cap to the input line and 2 resistors to control the op-amp gain. We can continue to place parts and wire them up in the same fashion to complete the circuit schematic. From here, we can switch to the PCB layout and see that all the place parts with their corresponding references are in the components bin waiting to be placed. Before placing the components, it is advised that you set design rules for the project. This is done in the Design Rule Manager from the Technology menu. The Design Rule tab allows you to set clearances that apply to either the whole design or a specified subset of circuitry. These are then used both when routing manually or via the auto router. The Net Classes tab gives the ability to specify different trace and via style settings for different groups of connections. You can also specify whether via placement during routing should always use through-hole vias or whether the shortest rule range should be chosen automatically. Once design rules are set, you can pick components from the bin for placing, either by viewing all components or using the drop-down box and selecting tagged parts if there are any tagged in the schematic. To set the board edge ready for placement, select the 2D Graphics tool and make sure the layer selector at the bottom is set to board edge. For smaller boards, such as this one, it may be useful to use the middle scroll wheel of the mouse to zoom in and out for more control. Pressing O on the keyboard will set a false origin at the mouse pointer and set the design coordinates to 0 at this point. The colour will change to magenta to indicate the false origin is in use. Left-clicking will allow you to draw a board edge, and the measurements can help get an accurate board size. Left-clicking again will complete placement of the board. The components in PCB design are picked and placed in the same manner as the schematic. Let's click to start placement. Use the plus and minus keys to rotate and left-click to complete. The green rat nest lines indicate connections to be made based on nets and helps in determining orientation position for the components. If needed, the component identifiers can be moved independently of the actual component or can be turned off via the Edit Properties dialog. This process is repeated until all components are placed on the board. To manually route the board, you need to enter track mode from the selection bar and set the layer selector to the desired starting layer of the route. To start routing, left-click on the pad you will route from. Proteus will recognize the net the pin is connected to and change the track style automatically to match your defined design rules. Drag the mouse in the direction required, and the Follow Me routing feature will draw the track of best fit that obeys the design rules. A left-click on the end pad will commit the track in place. Like wiring the schematic, a left-click whilst routing will place an anchor allowing for change of direction of the route. You can just as easily manually place vias whilst routing to switch between layers. Pressing the spacebar will float a via at the end of the track, and a left click will place the via and switch routing to the associate layer. Aries will also allow you to route to or from a via that is on the same net. If you hold down the control button when routing, you will switch into curved routing mode, which is also fully design rule aware. The F8 key allows a fast and simple way to zoom out and review the whole board. A power plane can be placed at any time from the power plane generator in the Tools menu. Select the required net and layer and Proteus will place it for you. The power plane will step away from the board edge by the edge clearance specified in the Design Rule Manager. Once placed, the Edit Properties option can be selected by right-clicking on the edge of the plane. Here the zone fill can be set as needed. From here, routing can be completed manually or by using the Auto Router in the Tools menu. The Auto Router can be customized to suit your own preferences, but for the example used here, then a default setting will suffice. Click Begin Routing, and Aries will route the board for you within the constraints of the design rules specified earlier. Upon completion, any errors that may have been encountered will be listed at the bottom of the screen for review and action if needed. After completion, you may wish to tidy up the design. Here the parts references are quite large for the size of the board. These can be changed from the Technology menu in the Text Style option. Here set the font and height as desired. Other styles, such as graphics, although not used in this design, can be changed as well. If the PCB data is being sent to MCAD software for case design, you may first wish to import 3D models for the component parts. Step models can normally be found quite easily on the internet, and the process for importing and positioning them is very simple. The 3D viewer will give you a live preview of the PCB in 3 dimensions, and can also be used in bare board mode to inspect solder mask. When you have finished, a single step assembly file can be generated from the output menu in Aries. If the PCB data is being sent for manufacturing, you can also generate Gerber X2 files or an ODB++ file set. In this case, the pre-production checker will run first to test the board for some common errors.